Hi, today we are going to talk about yield, which is just another word for how much product we get out of our reaction. The first word I have listed here is theoretical yield. That's the amount of product that theoretically we're supposed to get out of our reaction. If we were to take our beakers in the lab, mix the reactants together, and get a product, theoretically it should be a certain amount that we've calculated. You all have become proficient at calculating the theoretical yield. Unfortunately, it's seldom obtained. The actual yield is the amount of product that we actually get in the lab. When we put our final product on the balance or in some other way measure it, the actual yield is what we actually get. And it's usually lower than the theoretical yield. Some of the reasons for this are that the reaction sometimes produces other products other than the ones that we have represented in our equation. Also, lab error and technique can also contribute to the problem. So those are some reasons that we see a lower actual yield. Now what we'd like to do is compare these in a useful equation. We call this percent yield. We'd like to know how these two actually compare. How well did we follow procedures and follow lab techniques, and how close to the theoretical yield are we? So we do that by dividing actual yield by the theoretical yield and multiplying by 100%. That gives us our percent yield, how close we are to getting the actual amount that we had calculated to get. So in order to calculate one of these, I've listed an example. Here I have a balanced equation for us, and the problem states that if we know we have 155 grams of calcium carbonate and 250 grams of hydrogen chloride, and we obtain 142 grams of this product here, calcium chloride, what is the percent yield? So we know the amount we start with, and we know the amount we end with, and we need to be able to say how close was this to the theoretical yield in our percent yield calculation. So let's start that calculation. We know from the problem we have 142 grams of calcium chloride. We need to then find the theoretical yield. So remember, in order to do that, we need to look at our balanced equation here, and we need to come up with a limiting reactant. So in order to do that, we start with the grams of each of our reactants, the calcium carbonate and the hydrochloric acid, and I've listed those right here. We multiply by the 1 mole of calcium carbonate is 100 grams of calcium carbonate per 1 mole, the molar mass. And here we multiply by the molar mass for hydrogen chloride. And these are the results we get: 1.55 moles of calcium carbonate and 6.85 moles of hydrogen chloride. Once we know that, we can use the mole-to-mole ratio then to go on and determine how much a spelling error here, how much reactant is actually used, and that gives us our limiting reactant. So we know from the 1.55 moles of calcium chloride here, and we multiply by the 2 moles of hydrogen chloride per every 1 mole of calcium chloride. That gives us 3.1 moles of hydrogen chloride. We know that that's the amount required for this reaction. And we also know from the last slide that 6.85 moles of hydrogen chloride are available. So that's plenty available. Therefore, the calcium carbonate is going to end up being the limiting reactant. Since we know the limiting reactant, we can now calculate the theoretical amount of product formed. So here are the number of moles of calcium chloride from the previous calculations. We have a 1-to-1 mole ratio between calcium chloride up here and between calcium carbonate, and the calcium chloride, the product. So we put that into our formula, and then we multiply by the molar mass for calcium chloride, and we get 172 grams of calcium chloride. That's the theoretical yield. That's the amount that theoretically, if everything were perfect and went just right, that is exactly the amount we would have. Now, since we know the theoretical yield, and we also know the actual yield, which was given to us in the initial problem, we can find the percent yield. So here we plug those values in, the actual yield being 142 grams, and the theoretical yield that we just calculated, 172 grams, multiply by 100, and we see that our percent yield is 82.6%. So that's 82.6%. It's that close to the actual amount that we should have had, the theoretical yield. So let's look at another problem. Here is a little practice problem for you if you would like to try this. Remember, we are just doing what we have learned, what you guys already know how to do. You're finding the theoretical yield by using what you know of how to find the limiting reactant. You're using lots and lots of calculating skills that you've already learned during this unit, and then you're just plugging those numbers into the formula for percent yield. So it's really not any harder than what you've already done. Here's the practice problem. If you want to pause after I read this, you can pause it, and then I'll show a slide with the answers on the next page here. If we react 6.85 times 10 to the fourth grams of carbon monoxide and 8.60 times 10 to the third grams of hydrogen, and we produce 3.57 times 10 to the fourth grams of methanol, what is our percent yield for methanol? Here's the solution. I restated the problem up at the top as well for you. First, you want to write a balanced equation, and here's that balanced equation there. Second, find the moles of each reactant available to be used. Here, these were determined by multiplying by the molar mass of those compounds. Once we found that, we find out how much of one of the reactants is needed. I just picked carbon monoxide. You could have picked the hydrogen as well. We'll see how this works. So I picked the carbon monoxide multiplied by the mole-to-mole ratio in the equation, 2 moles of hydrogen per 1 mole of carbon monoxide, and I got 4.90 times 10 to the third moles of hydrogen, and that is how much that is needed. So we only have, as we see from up here, 4.27 times 10 to the third moles of hydrogen. So hydrogen then is the limiting reactant. Since we know that hydrogen is the limiting reactant, we can now calculate the theoretical yield. So we take the amount of hydrogen that we do have, 4.27 times 10 to the third moles, multiply by the mole-to-mole ratio for the product methane that comes from the formula. We have 1 mole of methanol, per 2 moles of hydrogen, right here. And then we multiply by the molar mass for methanol, right here. And that gives us the amount of 6.86 times 10 to the fourth grams of methanol. That is the theoretical yield. And we plug the numbers into our equation to find the percent yield. The actual yield was given in the problem up here, 3.57 times 10 to the fourth grams of methanol. The theoretical yield we found right here, and that is 6.86 times 10 to the fourth grams of methanol. And we multiply that ratio by 100, and that gives us our percent yield. It's 52.0%, which is a terrible percent yield, but that's what we get. And hope that all made sense to you. Thanks a lot. We'll see you in class.